እንደምን አላችሁ የሳፐሪ አካዳሚ የፊዚክስ ሲሪስ ተከታታዮች። በዛሬ ፊዚክስ ቪዲዮአችን የምናየው ምንድነው አንዳንድ የተርሞዳይናሚክስ ጥያቄዎችን እና ኤግዛምፕሎችን የምናየው። እነዚህ የመጀመሪያው ኤግዛምፕሎቻችን ላይ 6 ጥያቄዎች የምናይ ሲሆን በሚቀጥሉት ቪዲዮዎች ደግሞ በተከታታይነት የሚለቀቁ ይሆናሉ። አሁን እዚህ ጋር የመጀመሪያው ጥያቄያችን የምናየው on a strange temperature scale አንድ ማናውቀው ቴምፕሬቸር ስኬል ላይ the freezing point of water -15 degrees S ተብሎ የተሰጠው። Now this freezing point of water, sometimes ice point ብለን ብንወስደው, it is the ice point or sometimes called the lowest fixed point ብለን ብንወስደው, and our boiling point ደግሞ 60 degrees S, which is simply the steam point ነው ብዬ ብወስድ, which is sometimes called the upper fixed point ተብሎ ቢሰጥ, it's asking us to develop a linear conversion between ይሄ ማናውቀው ቴምፕሬቸር ስኬል እና ሴልሺየስ ስኬል ላይ ኮንቨርት ለማድረግ የሚጠቅመን አንድ ሊኒየር ኢኩዌሽን አምጡ ነው። ናው ቴምፕሬቸር ኮንቨርዥን ላይ በአብዛኛውና ሁሉ ጊዜ የምናገኛቸው ኢኩዌሽኖች ሊኒየር ኮንቨርዥን የሚኖራቸው። ለምሳሌ ዲግሪስ ፋረንሃይት ስናገኝ that's 9/5 of degree Celsius plus 32 ነው የምንለው። this is a linear conversion አይደለ? y equals to mx plus b የሆነ ፎርሙላ ያላቸው which is called a linear conversion። ይሄ የሚጠይቀን ምንድነው? በማናውቀው ቴምፕሬቸር ስኬል ኤስ እና በሴልሺየስ ስኬል መካከል ይሄ የሚመስል ሊኒየር ኮንቨርዥን አምጡ ነው። ናው ይሄን ለመስራት የምንጠቀምበት አንድ ፕሪንሲፕል አለ። እሱ ምንድነው? አንድ ቴምፕሬቸር ስኬል እዚህ ጋር ቢኖረን suppose you have some temperature scale እና at this position አሁን ይሄ የሆነ ቴምፕሬቸር ስኬል ነው ልበል t. now suppose that this position is the upper fixed point እዚህ ጋር ነው the upper fixed point ወይም steam point ነው ብዬ ልውሰድ። upper fixed point suppose እዚህ ጋር ደግሞ ያለው is my lowest fixed point ብዬ ልውሰድ። so upper fixed point ማለት it is the steam point ተብሎ ነው የሚታወቀው። We call it the steam point because at this temperature we have a mixture. He measured የተደረገበት መጀመሪያ it is by using a mixture of ice, of water, and steam. That is steam እና water አንድ አደባልቀን በላተንሲ ሂት ህግ መሰረት እዚህ ጋር ቴምፕሬቸሩ ስለማይቀያየር at constant temperature ላይ የሆነ ፖይንት ወስደን ነው። እዚህ ጋር ደግሞ lowest fixed point ወይም ደግሞ ice point ብለን ብንወስድ which is a mixture እዚህ ጋር ደግሞ mixture of ice እና ውሃ ነው እዚህ ጋር። now እዚህ ጋር the ice is going to increase in temperature. water temperature ይሰጠው አይደለ? it's not going to increase in temperature but it's going to stay at the same temperature until the ice melts. ስለዚህ እነዚህ ሁለቱ positions are simply found at constant temperature. አሁን እነዚህ ሁለቱ ያለው እነዚህ ወስጄ በዚህ በቴምፕሬቸር ሙሉ ቴምፕሬቸር ስኬሉ እና በሎስት ፊክስድ ፖይንት ያለውን ዲስታንስ ሲካፈል ለአፐር ፊክስድ ፖይንት እና ለሎወስት ፊክስድ ፖይንት ያለው ዲስታንስ ባካፍላቸው ኮንስታንት ነው የሚሆኑት ነው የሚለው። that is እዚህ ጋር ያለው t ሲቀነስ እስከ ሎወስት ፊክስድ ፖይንት ሲካፈል ለመካከላቸው ያለው ወይም the upper fixed point ሲቀነስ the lowest fixed point is constant ነው የሚለው። so that's the same። እንደዛ ስለሆነ I can use the same principle እዚህ ጋር በዚህ በማላውቀው ቴምፕሬቸር ስኬል ላይ ለመስራት። now suppose ይሄ በማላውቀው ቴምፕሬቸር ስኬል ነው just ts ልበለው። now I have my upper fixed point at 60 and my lowest fixed point at -15 አለኝ። and suppose that ይሄ ደግሞ ቴምፕሬቸር ሴልሺየስ ስኬሉ ሴልሺየስ ነው ልበል። my upper temperature fixed point is 100 lowest ደግሞ 0 ነው እንትና ሴልሺየስ ላይ። ስለዚህ using my equation ከዚህ እስከዚህ ያለው ዲስታንስ ሲካፈል ከዚህ እስከዚህ ያለው ለዚህም ከዚህ እስከዚህ ያለው ዲስታንስ ሲካፈል ከዚህ እስከዚህ ያለው is the same ስላልን ts ሲቀነስ 15 ይሄ ከዚህ እስከዚህ ያለው ወይም ይሄ ከመጻፍ በኢኩዌሽን መልክ ብጽፈው the temperature s ሲቀነስ the lowest fixed point of s over the upper fixed point of s ሲቀነስ the lowest fixed point of s must be equal to the temperature Celsius ሲቀነስ the lowest fixed point of Celsius over the upper fixed point of Celsius ሲቀነስ the lowest fixed point of Celsius ነው የሚሆነው። so using this equation እንደሆነ ማገኘው that's ts ሲቀነስ the lowest fixed point of ts it's -15 over the upper fixed point it's 60 is also -15 equals the Celsius the lowest fixed point is 0 over the upper fixed point is 100 ሲቀነስ the lowest fixed point ከእንደገና is 0. now this እዚህ ጋር ያለኝ is the same በኢኩዌሽን መልክ ይሄን ብጽፈው ts እዚህ +15 ይመጣል over 75 is equal to tc over 100 ይመጣል። if I multiply both sides by 100 tc ለማግኘት I get tc equals to ts plus 15 over 75 ሲባዛ በ100. If I simplify this by 25, this is 3. By 25, this is 4. So I have TC, which is 4/3 of TS plus 15 ይመጣል ማለት ነው. So this is my linear conversion factor between ሁለቱ temperature scales. This is linear. This also works. So እንደዛ ማለት at any temperature TS, I can convert this to TC using this equation ማለት ነው. Now let's go to the second equation. Second equation ምንድን ነው የሚለው? We have a gas. That gas is contained inside a volume. So we have a volume, fixed volume of 8 liters. And we also have a room temperature of 20 degrees Celsius with a pressure of 9 atmospheres. So what are we asked to determine? The number of moles in and the number of molecules, capital N. So let me identify our given. So our given includes, so the given we have a volume of 8 liters, which is the same as 8 times 10 to the minus 3 meter cube. We also have our temperature. Temperature by degrees Celsius ተሰጠው በአብሶሉት ቴምፕሬቸር መቀመጥ ስላለበት ወደ ኬልቪን ቀይሯለሁ, which is 293 Kelvin degrees የለውም እዚህ ጋር. We also have our pressure, which is given as 9 atmospheres, which is the same as 909 kilopascals ነው የሚመጣው. So determine the number of moles ነው የሚለው. Now to do this, we use the ideal gas equation, ወይም ደግሞ the equation of a state, PV equals to nRT. So the number of moles in becomes a PV over RT. So substituting in all my numbers, then a pressure is 909. አሁን እዚህ ጋር ኪሎ ፓስካል የሚለው ለዩኒት ኮንቨርጅን እንዲሆንልኝ times 10 ፓስካል የሚለው ቦታ ምንድን ነው ከተው ኒውተን per meter square. volume አለኝ, which is 8 times 10 to the minus 3 meter cubed. Divided for the universal gas constant R, which is always a constant ቁጥር, that's 8.314 joules per mole Kelvin, multiplied by my absolute temperature, which is 293 Kelvin. Now እዚህ ጋር ዩኒቶቹን ባጣፋ for my dimensional analysis, Kelvin by Kelvin, I can also remove 1 meter square by 1 meter square. ስለዚህ እዚህ ጋር የሚቀረው ኒውተን ሜትር ይመጣል. So ይሄ ቁጥር መጨረሻ ስንት ነው የሚመጣው? 7272 ከላይ ሞል ወደ ላይ ይወጣል. So I'm going to be left with ሞል አለኝ multiplied by ከላይ ደግሞ ኒውተን ሜትር አለኝ, ኒውተን ሜትርስ divided for ከታች ደግሞ ያሉት 2436 ጁል ነው የሚቀረው. አሁን ኒውተን ሜትር ማለት ጁል ማለት ነው. ኒውተን ሜትር is the same as to ጁል. ስለዚህ አንድ ጁል በኒውተን ሜትር ጁል ከጠፋ this equation becomes 2.9 moles. So I have 2.9 moles within my system. Now the second equation, what is the number of particles within the system የሚለው ለማግኘት we can use the equation. The number of particles N is the number of moles multiplied by Avogadro's number. Avogadro's number is a constant given as 6.23 times 10 to the 23 per mole ነው የሚሆነው. So እዚህ ጋር በከተው I have my number of molecules N, which is 2.9 moles multiplied by Avogadro's number of 6.23 times 10 to the 23 per mole ነው የሚመጣው. So ሙሉ በሙሉ ይጣፋና I'm left with 1.86 times 10 to the 23. Unitless, unit alone, because this is a number of particles ፈለግ ነው. Now ሶስተኛው question. Now question number 3 ምንድን ነው የሚለው? Just 9 grams of water, we have mass of water. 9 grams of water is placed inside a 2 liter, we have our volume, and heated to 500 degrees Celsius temperature አለን. So the question is, what is the pressure inside the container? Now ይሄን ለመስራት we have አንድ ነገር መገናዘብ አለብን. እሱ ምንድነው? number 1 pressure ኩከራችን እዚህ ጋር ቢኖር, suppose this is our pressure cooker ብለው, this is our pressure cooker ቢሆን መጀመሪያ initially we going to have is used, we going to have an air አይደለ? we have air trapped አለን. ኦሪጂናሊ ሳንሰጋው በፊት የገባ አየር አለ. ከዛ በኋላ ደግሞ we added some water is used. ከዛ ዋተሩን ሂት ስናደርገው ዋተሩ ምን ያደርጋል? ወደ ላይ ኢቫፖሬት ያደርጋል. ስለዚህ we gonna have vapor pressure ደግሞ ይኖረናል. So we're going to have vapor pressure. So my is that የሚኖረው total pressure በሁለት ምክንያት ነው የሚሆነው ማለት ነው. It's going to be due to the pressure of the air trapped ይኖራል መጀመሪያ ላይ ሲደመር due to the pressure because of ከቬፐር pressure ወይም ውሃው እዛው ሂት ሲሆን ቬፐራይዝ አድርገው በስቲም ምክንያት ስቲም that is water in the form of gas እዛ ውስጥ ያለው የሚያመጣው ፕሬሸር እና በኦሪጂናል ትራፕድ የሆነው ፕሬሸር ተደምሮ ነው ቶታል ፕሬሸራችን የሚሰጥ። ስለዚህ የሁለቱም የሚያገኝበት መንገድ ያስፈልጋል ማለት ነው። So number 1, let me try to calculate the pressure of the pressure of the water vapor ልፈልግ። Now to find the pressure of the water vapor by ideal gas equation ወይም ደግሞ በequation of the state PV equals to nRT ብዬ my pressure equals to nRT over V ብዬ መጀመር ይችላል። Now from here N, that's the number of moles, can be given as given mass divided for molar mass አይደለ? So እዚህ ጋር substitute ባደርግ my pressure becomes given mass times R times T over molar mass times volume. So what's my given mass? እዚህ ጋር I have 9 grams of given mass times 8.314 joules per mole Kelvin multiplied by an absolute temperature of 500 degrees Celsius ይቀየራል። ይሄ ሲቀየር 773 Kelvin ነው የሚመጣው multiplied by 773 Kelvin ሲካፈል for my molar mass of water which is 18 grams per mole multiplied by የተሰጠኝ volume of 2 liters 2 liters ደግሞ ማለት 2 times 10 to the minus 3 meter cube ነው 2 times 10 to the minus 3 meter cube. Now using dimensional analysis I can remove my values. I can remove my grams with my grams. I can remove the mole with moles. I can also remove the Kelvin with the Kelvin. ስለዛ እዚህ ጋር ምንድነው የሚቀረኝ ጁል ይቀረኛል እዚህ አንድ ሌላ ደግሞ እዚህ ጋር ይቀረኛል ሜትር ኪዩብ ደግሞ ይቀረኛል በተጨማሪ ደግሞ እዚህ ጋር ዩኒቶቹን እየቀያየርኩኝ ብሰራው ጁል የሚለውን በኒውተን ሜትር ባስቀምጠው ኒውተን ሜትር so 1 ሜትር በ1 ሜትር ቢጠፋ ኒውተን ፐር ሜትር ስኩዌር ይቀረኛል which is the unit of pressure አይደለ pascals. So ይሄን ሶልቭ ባደርግ I have my pressure which equals to 1.61 megapascals ወይም ደግሞ 1.61 times 10 to the 6th pascal ማለት ነው። አሁን ይሄ ኦሪጂናሊ actually ቁጥሩ ስለካው is 1,606,680.5 ነው የሚመጣው which is approximately 1.6 megapascals. So this is the pressure due to the water vapor አይደለ እዛ ውስጥ ያለው water vapor የሚያመጣው pressure ጋር እኩል ነው። Now how can I find ሌላኛው ደግሞ the pressure due to the air trapped? Now እሱን ለመስራት we have to use an equation አይደለ Now I can use the equation which comes to pressure law ወይ pressure law ተነስቼ that is P1 over T1 equals to P2 over T2 ከሚለው መነሳት I can calculate the other pressure ወይም ደግሞ the pressure due to the air trapped. Now the pressure due to the air trapped ለመጠቀም I should use the initial pressure ነው የሚሆነው እሱ እና initial temperature ነው የምንጠቀመው. Now suppose that initial temperature since you're cooking something ውሃ ውስጥ ከታችሁ is most probably the initial pressure is going to be the atmospheric pressure አይደለ because you're cooking something መጀመሪያ pressure ኩከሩ ተከፍቶ ነው ያለው so atmospheric pressure ይኖራል. The first temperature ደግሞ room temperature ነው ልበል which is approximately 20 degrees Celsius ብል that's about 293 Kelvin ነው የሚመጣው. So if I suppose this is my temperature ብዬ ከወሰድኩኝ I also have my second pressure ደግሞ አግኝቻለሁ ሂት ከተደረገ በኋላ to be around the 1.61 megapascal ያለው ማለት ነው which is 1.61 megapascals and I know my final temperature is 500 degrees Celsius which is 773 Kelvin. So ይሄን equation ይዤ if I substitute ቁጥሮችን እዚህ ውስጥ ከዚህ I can get my value of P1 to be T1 to be my pressure of P1 to be equals to T1 over T2 into P2 አይደለም የሚሆነው from my equation. So ከዚህ ተነስቼ ከፈለኩኝ በዚህ this is my first equation ማግኘት የምችልበት መልክ አንዱ ይሄ ነው የሚሆነው ወይም በሌላኛው ደግሞ ማድረግ ይችላል I can use another substitution እዚህ ጋር sorry ሌላኛው substitution ደግሞ ምንድነው የሚሆነው ከገና አንድ atmospheric pressure አለኝ ብያለሁ አይደለ suppose ይሄ my P1 atmospheric pressure ውጪ ያለው ነው now atmospheric pressure እዚህ ጋር P1 P2 ነው የሚለው this is ይሄ ዝም ብሎ originally ከወሰድ ነው ይሄ ሳይከደም በፊት this is before ክሎዥር ሳይከደን በፊት ያለው ሲቹዌሽን ነው። አሁን ግን ፕሬሸር ያለው ከተከደነ በኋላ ነው። ከተከደነ በኋላ ስለሚሆን ስለተከደነ P1 ከአትሞስፌሩ ጋር ኢኳል አይሆንም። ኦሪጂናሊ we can also identify that ደግሞ ቀጥሎ ደግሞ at under position my P2 እዚህ ጋር ይሄን ቁጥር ሳይሆን አትሞስፌሪክ ፕሬሸር መውሰድ ይችላል። that is ከመከደኑ ይሄን አትሞስፌሪክ ብለው P2 ደግሞ አላቅም ራሱ ብለው ሳይከደን በፊት አትሞስፌሪክ ፕሬሸር ቴምፕሬቸር ይሄ ከተከደነ በኋላ I don't know its pressure but I know its temperature አይደለ? So using my equation original እንዳስቀምጥ ነው I can identify that P1 over T1 equals to P2 over T2 ማለት P2 የምፈልገው in which my value of P2 becomes T2 over T1 times P1 ይመጣል። So my P2 becomes what's my T2? That's 773 Kelvin over what's my T1? 293 Kelvin times my P1 is atmospheric pressure 101 kilopascals. Now solving this I'm gonna get my value of P2 to be approximately 262 kilopascals ይመጣል። So from this I have derived የኔን total pressure. So since the total pressure is pressure due to the water vapor ሲደመር pressure due to the air trapped አለ የዚህን አግኝቻለሁ to be approximately about 1.61 megapascals plus the pressure of the air trap ደግሞ አግኝቻለሁ 262 kilopascals ይህ ሲደመር this gives a value of 1.872 megapascals. So my total pressure inside the pressure cooker is going to be 1.872 megapascals. So from here the total pressure ያገኘነው equals to በሙቀቱ ምክንያት ኢቫፖሬት በሚያደርገው ውሃ የሚመጣው ፕሬሸር ሲደመር መጀመሪያ ድስቱ ሲከደን የገባው አየር የሚያመጣው ፕሬሸር ሁለቱ ተደምረው ነው ይሄን ቶታል ፕሬሸር የሚሰጡ ማለት ነው። ወደ የሚቀጥለው ጥያቄ ደግሞ ስናልፍ we have 1 mole of oxygen አለ we have 1 mole of oxygen gas pressure 6 atmospheres and the temperature of 27 degrees Celsius ላይ ይገኛል። Now if the gas is heated at constant volume the pressure is tripled what is TF? now እዚህ ጋር ሁለተኛው ላይ የምናየው ምንድነው ቮልዩም ኮንስታንት ሆኖ but እዚህ ጋር የሚቀየረው ምን ከሆነ ፕሬሸሩ የሚቀየር ከሆነ that we have change in pressure እና change in temperature ካለን የምንጠቀመው ህግ የማን ህግ ነው የሚሆነው አሞንቶቭስ ሎ የሚባለው አሞንቶቭስ ሎ የሚባል ነው የምንጠቀመው sometimes pressure ሎ ይባላል። ሁለተኛው ላይ ደግሞ ስናይ gas is heated until both pressure and volume are doubled find TF ነው የሚለው so እዚህ ጋር pressure change ያደርጋል because it's doubled volume change ያደርጋል because it's doubled temperature change ያደርጋል because TF ፈልጉ ስላለን እነዚህ ሶስቱ ቬሪብል ከተቀያየሩ ደግሞ we use the combined gas law የሚባለው የምንጠቀመው እዚህ ጋር ደግሞ the combined gas law የሚባለው so let us use እነዚህን ህጎች to solve the questions. So for A we have the gas just at constant volume doesn't change but pressure is tripled አይደለ so the second pressure or the final pressure final እንበለው እዚህ since it's tripled becomes 3 times the initial pressure አይደለ so what is TF ነው የሚለው now using Amontov's law P1 over T1 equals to P2 over T2 I can find my value of T2 now ከፈለኩኝ እዚህ ጋር I can say given ብዬ given my first OCP initial atmosphere is 6 atmospheres ነው ዩኒት መቀየር አስፈላጊ አይደለም because the ratio ስለሚጣፋ መጨረሻ ላይ we also have temperature initially 27 degrees Celsius 27 ማለት 300 Kelvin አለኝ so from here I can know that T2 ወይም ደግሞ my final temperature ማለት ነው is going to equal to P2 over P1 times my T1 ይመጣል አይደለ so from here what is my P2 P2 is 3 times P1 አይደለ over P1 አለ originally times the temperature of 300 Kelvin so P1 ከተጣፋ 3 times 300 Kelvin 900 Kelvin ይመጣል ማለት ነው so my temperature tripled so keeping the volume constant and then tripling the pressure is going to cause my temperature to triple so this shows that there is a direct relationship between pressure and temperature this implies there is a direct relationship between temperature and pressure ማለት ነው። Okay, so what's the next question? By using Amontov's law. በአሞንቶቭስ ሎ መሰረት ማለት ነው። the next equation ወይም the next question ደግሞ እንደሚለው እዚህ if the gas is heated until both pressure and volume are doubled, ስለዛ my pressure final double the original ነው የሚሆነው። ስለዛ we can use the combined gas law because the pressure is changing, the volume is changing, temperature is changing ስለሆነ using the combined gas law of P1 V1 over T1 equals to P2 V2 over T2 ለመጠቀም I can find that T2 equals to P1 P2 V2 over P1 V1 times T1 ይመጣል። So my T2 is my second pressure or simply final pressure is 2P1. My second volume is also 2V1 over P1 V1 times T1 አለ. This becomes 4P1 V1 over P1 V1 times T1. So ይህ ከተጣፋ we have 4T1. ስለዛ 4 times my initial temperature which is 300 Kelvin ከሆነ 1200 Kelvin. And so doubling both the pressure and the volume caused my temperature to quadruple ማለት ነው. Let us go to the fifth question. Now the fifth question says that 1 cubic meters of air, so we have a volume of 1 cubic meters of air which is simply found at 20 degrees Celsius. So it's found at 20 degrees Celsius, that's 293 Kelvin, and 1 atmospheric pressure, that's a pressure of 101 kilopascals ማለት ነው. Now for Avogadro's number of molecules, so find the number of moles. Second, for air, Avogadro's number of molecules has a mass of 28.8 grams. So calculate the mass of 1 cubic meter of air and compare the results with the tabulated density of air. Now for the first equation, we can simply use the ideal gas equation ከእንደገና PV equals to nRT such that n equals the number of moles ስለሚጠይቅ PV over RT. So what is my pressure given here? That's 1 atmospheric pressure, no, 101 kilo times 10 with 3 Pascal million Newton per meter square largo multiplied by a volume of 1 meter cubed divided for 8.314 joules per mole Kelvin multiplied by temperature of 293 Kelvin. So Kelvin by Kelvin ይጣፋል 1 meter square by 1 meter ከተጣፋ እዚህ ጋር ኒውተን ሜትር ይቀራል which is equal to joule. ይሄን በዚህ ይጣፋና የሚቀረው ማን ነው የሚሆነው? ሞል ይቀራል። ሞል ላይ ዞሮ ይቀራል። So this gives me 41.46 mole አለኝ. So 1 cubic meter of air at ideal temperature of 20 degrees Celsius and at atmospheric pressure consists of 41.46 moles. Now 20 degrees Celsius ማለት is room temperature አይደለ? And atmospheric pressure ደግሞ ideal temperature ነው. So conditions in which we have room temperature አንዳንዶች መጽሐፎች ላይ 20 ዲግሪ አንዳንዶች ላይ 25 ዲግሪ ሴልሺየስ ይላሉ. And atmospheric pressure is called standard temperature and pressure. So what is standard temperature and pressure by my calculation? እዚህ ጋር በሰራነው calculation መሰረት 1 cubic meter of air is going to consist of 41.46 moles air ማለት ነው. So the second question second question simply says that for an Avogadro's number of molecules. Now what does an Avogadro's number of molecules ማለት ምን ማለት ነው? So Avogadro's number of molecules ማሳቸው ይሄ ነው ከተባለ ምን ማለት ነው? ይሄ ለማለት let us define molar mass. Now molar mass ማለት is the mass of 1 mole of a substance. Now we know that 1 mole of a substance consists of how many number of molecules? It consists of Avogadro's number of molecules አይደለ? Avogadro's number of molecules አሉት 1 ሞል። ስለዚህ mass of 1 mole of a substance ማለት mass of 1 Avogadro's number of molecules of a substance ከማለት ጋር እኩል ነው። ስለዚህ Avogadro's number of molecules has a mass of 28.8 grams ማለት the molar mass of air ማለት ነው በሌላኛው በኩል is equal to 28.8 grams per mole እያለ ነው ማለት ነው። So ይሄ ካለን what is the mass of 1 cubic meter of air? So using the simple conversion we know that the number of moles is mass over molar mass አይደለ? ስለዚህ the mass is number of moles n times our molar mass. So the moles አግኝተናል እዚህ ጋር we have found our moles here. We we have 41.46 moles multiplied by what's our molar mass? 28.8 grams per mole. So molar ከተጣፋ this becomes 1198.23 grams ነው የሚኖረው ማለት ነው። approximately 1.2 kilograms. ስለዛ 1 cubic meter of air at a standard temperature and pressure consists of 1.2 kilograms of air. Now from here we can calculate the density of air ከፈለግን አይደለ? እኛ የፈለግነው. Now we know that density is mass over volume. So what is the mass that we've got? We've got our mass to be 1198.23 grams over volume of 1. That's 1 cubic meters. So 1 meter cube. So this is the density of air. So the density of air እኛ ያገኘነው calculated density of air is 1198.23 grams per meter cube or 1.2 kilograms per meter cube ነው የሚሆነው ማለት ነው። Now at C ላይ ደግሞ ያለው ለመስራት we have to find the tabulated value. በሳይንቲስቶች ካልኩሌት ተደርጎ originally real የሆነውን value ነው የምናገኘው። Now እሱ ላይ ስንፈልግ ከብዙ ሪሶርሶች we have that the tabulated mass of volume density of air. ይሄ air በሳይንቲስቶች ካልኩሌት የተደረገው ይሄ value ነው። so ከኛ ጋር ኮምፔር ሲደረግ ስንት ነው? እኛ ካልኩሌት ያደረግነው hours the density እኛ ካልኩሌት ያደረግነው density አሁን it is 1198.23 grams per meter cube ነው። the density of air ሳይንቲስቶች ደግሞ ያገኙት 1204.1 gram per meter cube ነው። so ስናነጻጽረው these two are approximately the same አይደለ? so approximately equal ስለሆኑ we are also በጣም accurate ነን። ወይ ከፈለግን ደግሞ we can also try to do this quantitatively በቁጥር መልክ ስንገልጽ ሬሽዮአቸውን ብንወስድ that is እኛ ያገኘነውን ሲካፈል ለኦሪጂናሉ ስናደርግ we get a value which is approximately about 0.995. that is 99.5%. so our value is within 99.5% of yagnus, so we are accurate. This implies we have an error rate of approximately 0.5%, which is very small, and thus we are approximately the same ማለት our conclusion and our number is valid ማለት ነው። እና ለዚህ ቪዲዮ መጨረሻውን ጥያቄ ላይ ስንደርስ question number 6 we have a room of volume V. so the room consists of volume V, it having an equivalent molar mass of air. now this means that all the air is homogeneous. so homogeneous air አለው that's ተመሳሳይ የሆነ the same air አንድ አይነት air ነው ያለው ሙሉ ወይ ኦክሲጅን ሊሆን ይችላል ናይትሮጅን ሊሆን ይችላል ወይ አርገን ወይ ሂሊየም በዛ type of gas ብቻ ነው የተሞላው። now if the temperature of one room የዛ room temperature ከT1 ወደ T2 raise ቢደረግ what mass of air is going to leave the room ነው የሚለው። now assume that the pressure is the same. now መጀመሪያ we know that it's a room እስከሆነ ድረስ V is constant አይደለ? unless originally construct ሲደረግ የሩሙን volume ለመቀየር ከተሰራ በስተቀር is going to be constant volume ይኖረዋል። ቴምፕሬቸር ደግሞ ከT1 ወደ T2 ነው የተደረገው። we also see that pressure also the same እዚህ ጋር አስቀምጦልናል። so P naught is constant. the question is what mass of air is going to leave the room የሩሙ ቴምፕሬቸር ካነሳ ነው። now to solve this question we can begin with the ideal gas equation ከእንደገና. now we know that P1 equals to P2 which is P naught because constant it's the same for all ስላለ. we also know that V1 is V2 which is V because it's a room. V is constant and thus PV equals to nRT ከሚለው equation ለእያንዳንዱ ባይ at T1 የኔ P is P naught, V is going to be V, የኔ N is going to be N1 times R of T1 አገኛለሁ። at the second temperature T2 ላይ ደግሞ again P naught V አገኛለሁ። እዚህ ብቻ N2 RT2 ነው ማገኘው። now what mass of air is going to leave the room ነው ጥያቄው። so the change in mass must equal to mass 1 ሲቀነስ mass 2. ይሄን ፖዚቲቭ አውቀን ያደረግነው የቀየርነው ቦታው that is because we know that mass 1 is greater than mass 2 because some air has left the room, and since we want our change to be positive m1 minus m2 ብለን እናስብ. and so we also know that the number of moles is mass over molar mass አይደለ? so ይሄን እዚህ ጋር substitute ባደረገው P naught V equals to mass 1 over molar mass multiplied by RT1 ከእንደገና for ይሄ RT1 RT2 ደግሞ mass 2 ይመጣል። የማስ 1 ነው። molar mass is the same ብለናል። equivalent molar mass አለው times R of T2. Now change in mass ብፈልግ for either side from the first equation I can find mass 1 ከዚህ mass 1 is going to equal to P naught V of molar mass divided for RT1 ከዚህ my second mass 2 is again P naught V over molar mass over RT2 ይመጣል። And so ከነዚህ ሁለቱ I can find change in M which is mass 1 ሲቀነስ mass 2 ቦታ ውስጥ ብከታቸው what is mass 1 that is P naught V molar mass over RT1 ሲቀነስ what's mass 2 P naught V M over RT2. Now P naught V M over R is the same, so it's common for both sides. So common will be soon about out. I get a P naught V M over R into 1 over T1 sequence 1 over T2 again. So this is my change in mass. So this amount of mass of air is going to leave the room because of the increase in temperature. So this will be the end of this first series. Series ending. If you have any questions, comments, or suggestions, please leave them down below. So until next time, bye bye.